Okay, part 2 on the review, and this is all in the simplex method. And so we want to solve this subject to these constraints. Now this we don't need the simplex method because I have two variables. I could call this x and y, and I could actually graph them. We'd have x1 down here and x2 down here, and we could solve that. But we want to use the simplex method, which is a method to solve systems like this that have more than two variables. Okay, and the way that we do this is we're going to use the software that I gave you the link to, and you should be able to hit on. So I'm going to go ahead and, let's see if I can do this. I'm going to try to be fancy on this here. Okay, how about that? I'm going to split my screen. So I got two screens here. So this is the simplex tool that again, I gave you the link to. And we just need to enter this into, or I can write on the left side, but not the right side over here. So I'm going to push examples and just find one that looks close enough, right? Okay, so I'm going to, I can go ahead and edit and change. I'm going to go ahead and pick this one so you can see. I want to maximize z equals 3x1 plus 2x2, and that's it. Oops, subject, sorry, you got to include that. Subject to negative 3x1 plus 2x2, oops, less than or equal to 8, so you got to get rid of other stuff, less than or equal to 8. And then we got 5, I'm going to go ahead and get rid of this whole one here. 5x1 plus 2x2 less than, so you want to make sure you get the less than equal to 16. And x1 and x2 are positive. You don't need to put those in there because we make that assumption on here. And so I'm going to solve it. And it shows all the tables for this, and it tells you, it even tells you z is 14, x1 is 1, x2 is 5, 5. So the question is, what do I want you to write down? I want you to write down the final tableau here so that I can see that you did it. So you're going to write down final tableau. Sorry, I'm writing vertically here. Actually, I don't need to do that. Take this off. So we're just going to go 0, 1, negative 0.3125, 0.1875, 0, 5.5, and then 1, 0, negative 0.125, 0.125, 0, 1, and then 0, 0, 0.25, 0.75, 1, and 14. And this right here, this bottom row is my 0, that's my maximum. And so I want you to tell me that the max is 14. Well, it's z equals 14 in this case. When x1 equals 1 and x2 equals 5.5, and where that comes from is this is x1 and x2. x1 is 1, x2 is 5.5. Now again, we can do this manually. We can solve this tableau manually, but we're using our software to do that. Okay, so there's 24. 28. We're going to do the same thing over here. And I'm going to go ahead and just use the same setup that I have here. here. Oops. I'm going to say, okay, I want to maximize z equals 10x1 plus 24x2 plus 13x3 subject to x1 plus 6x2 plus 3x3 less than or equal to 36. Don't forget to change the other side. 3x1 plus 6x2 plus 6x3. Again, the spacing doesn't matter on here. Less than or equal to 45. 5x1. It might be just even easier to just type it from the get-go. 6x2 plus x3 less than or equal to 46. And again, they're all positive, the x1, x2, x3, so we don't need to include those, so I'm going to go ahead and solve. There's my solution. And so again, for you to show me that you did this like this, I'm going to say, you're going to say the max. Uh-oh. There we go. The max is z equals 163 when x1 equals 3, x2 equals 5, x3 equals 1. And if I come down and look at the final tableau, I got x1, x2, that's all I'm really worried about you having here. 0.28, you can round these. Right, 0, 0, 1. 3. And then 1, 0, 0. Just copying from over here, write that one right there. And then I got 1, oops, 0, 0, 0, 2, 1, 1, 1, 1, 6, 3. Z is actually this guy right here, so Z is 163, that's where that comes from. X2 is 5. X3 is 1, right? And X1 is 3. That's how you read it off of there. Okay. So that gets us to, I believe we've got the last one here, or maybe there's a couple more problems here. I do want to make sure I'm watching the time. Oops. Okay, we're going to keep rolling on here. And so I'm not going to use here. I'm not going to use the simplex method on these. I'm going to set it up and then let you do the simplex method because I think you see how to set it up here. So we've got a Craftsman makes two. So the battle here is going from the words to the mathematics, and then once you do that, then you can solve it. You should be able to solve it. So Craftsman makes two kind of jewelry boxes: oval and square. How many of each should be produced? So let's set x equal the number of oval boxes to produce. Y would be the number of square boxes to produce. And I want to maximize my profit. So profit P equals $3 profit in the oval box, so 3x, and $4 on the square box, right? And when you sell thousands, that adds up. If you sell 10, it doesn't. Okay, so my constraints will be, let's see, oval box is 30 minutes of machine, 20 finishing. Now I'm reading the details. Square 20 machine, 40 finishing. Machine is 600 minutes a day. Finishing is 800. So the oval box requires 30 minutes of machine work. So for the machine, 30x, and then the square box is 20y. And machine work is limited to 600 minutes. Then we have finish. I like writing what I'm doing here. 20 minutes of finishing for the oval box and 40 minutes of finishing for the square box. And we only have 800 minutes there, and of course x is positive and y is positive. So go ahead and do that on the simplex method to solve that. Okay, to me this is the battle, right? 46, spring PTA prepares goodie bags to sell to elementary school. I think that's my last one, yeah. Sorry. Goodie bags to sell. Like always had one eye on the clock here. Goodie bags at elementary school carnival. Each bag contains jelly beans, candy, and gum in the following amounts. Okay, so small size has 16 jelly beans. Oh, these are by numbers, okay. And we've got pieces available here. Small bags sell. We want to maximize the receipts. Oops. Maximize total receipts. Which means just the income. Not the net income, but the gross income, or the revenue. Okay, so revenue, R would be, oh look, I can't write anything down if I don't have any variables. So let's let L equal the number of large bags sold. Actually, I'm not going to use L because it looks like the number 1. So let's let X equal large bags, Y equals the number of small bags. So we're going to have $1. Small bags are $1. See, look, I messed these up. I'm going to call X the small. It does not matter, but the first variable we used is small, so that's going to be X. Just makes me less likely to make a mistake. Large bags are $1.50. So there's my revenue. And I've got it. So if I want to maximize receipts, I got to have my constraints. And here's my jelly beans. So I've got 16 jelly beans in the small. 16x plus 20y has to be less than or equal to 1320. 8 of the candy, 8x plus 16y has to be less than or equal to 912. And 5x plus 3y less than or equal to 315. And of course, x and y are bigger than or equal to 0. Okay, so actually let's go ahead and do this one. Just to run through it one time here, or once again. So we're going to maximize. Okay, so I'm going to come over here and say maximize z equals x plus 1.5y. And it's subject to 16x plus 20y less than or equal to 1320. 8x plus 16y less than or equal to 912. 5x plus 3y less than or equal to 315. And again, x and y are positive. We don't need that, so I'm going to solve it. And I've got, so the max revenue is $93 when x equals 30 and y equals 42. And again, I want you to write this tableau down here. I'm not going to do it, but you know from the last earlier problems what you need to put there and what those numbers mean. This one means, oh look, x is 30 at the top, y is 42, and then z over here, z is 93. Okay, so we're good there. And then the question says, are all of each items used? Well, I don't know. We need, in order to check that, we need to plug my x and y into the above. So here's b. So it'd be 16 x 16 times 30 plus 20 times 42. What was that? 8 times 30 plus 16 times 42. I'm just plugging these into my x's and y's to see what they end up being, because it asks if all of them were used up. Here's how much I have right here, so I'm going to see what these values are. So I've got 16 times 30 plus 20 times 42, 1320. So I'm going to go ahead and answer the question. We used all the jelly beans. 8 times 30 plus 16 times 42 is 912. We used all the, what was that middle one? Candy. And then 5 times 30 plus 3 times 42, 276. We did not use all the gum. Okay, so there you go. So make sure you answer the questions when they're being, as to what's being asked in context, and you're good. All right, there you go.